So our goal is to find intervals where a function is increasing or decreasing and locate the local extrema. So we want to find where stuff is increasing or decreasing on f of x. When I say a function f of x is increasing or decreasing, and we're going to instead of find local extrema. So we're not going to be on a closed interval anymore, and that will make a difference. When we were on a closed interval, we had to consider the endpoints. An open interval has no endpoints, so we need some other method to be able to determine if we have a maximum or a minimum. We still find the critical points the same way. We take the derivative, set it equal to 0, find where the derivative does not exist. Those still give us our possible maxes and mins. But how do we tell if they're a max or a min? So I want to take this function and graph it and compare it to its derivative. See if we can find any commonalities. So y equals x squared minus 5x minus 6. Without a calculator, let's see if we can graph this fairly accurately. Where would my zeros be on this? X equals 6, x equals negative 1. Oh, you're talking about the y-intercept as well. So 0, 1, 2, 3, 5, 6 is the y-intercept. If we factor really quick, we can find the x-intercepts. 1, 2, 3, 4, 5, 6. Thank you. Negative 1. How can I find the vertex for this? Just some old school math review. You could actually use the derivative now, because we know the vertex would be at a minimum. Or, do you remember the formula negative b over 2a? The x-coordinate of your vertex. It's the first half of the quadratic formula, or first piece. So negative b, and then forget the plus or minus square root of b squared. So 5 over 2, so 2.5 would be our vertex. 2.5. And if we plugged it back in, that's a little bit harder without a calculator. 5 halves squared is 25 fourths minus 10 halves minus 6. How would I add all those fractions together? What do I need?
Common denominator.
Common denominator. So 25 fourths minus 20 halves minus 20. Thank you. Minus 24 fourths. So we get negative 19, which is negative 4.7. It doesn't. So I'm trying to figure out what I did wrong. So we plug in 0, get negative 6 for the y value, or the y-intercept. Did I factor correctly? Negative 6 times negative 1 makes negative 6, negative 6 plus 5. I know the formula is negative b over 2a. Negative outside of negative is a positive. 2 times 1 is 2. 5 over 2 squared is 25 fourths. Let's look at the actual picture then. I'm not sure where I went wrong. to x squared minus 5x. Can anyone else see where I went wrong?
No.
So they're getting a way lower number,
Yeah.
like negative 14 point. Oh, it's because I can't multiply. 5 halves times 5. I did 5 plus 5 in my head, not 5 times 5.
That was 20.
25, which is 50. Details. Which is negative 49 over 4. Okay. At least I didn't screw up the calculus. So it's 2.5 and like down here.
Tired.
So that wasn't super important to the lesson, just I wanted to try and review some old school stuff. Okay. So there's our quadratic. So when we are trying to do this, we're trying to locate the maximums and the minimums. What did we know about the derivative at this value, at the vertex?
0.
Why is the derivative here 0? Must be a horizontal tangent line. So we know our derivative there is 0. So let's see what else happens with the derivative. And again, we're trying to find some commonalities so that we could then find out more information besides just the max and the min. So the derivative would be 2x minus 5. So we would start at negative 5, and we'd go up 2 over 1. So our graph has been kind of split in two. We are considering, come on, we're considering, well, what happens on this part of our graph and compare it to what happens on this part of our derivative. So what does the left side of the graph have in common compared to the right side of f of x? So not of f prime, f of x right now. What's happening as we travel along the graph until we hit this vertex, and then it changes. So I'm traveling, 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 traveling. Something changes as soon as I hit here. And now I'm doing something different as I travel.
That was one derivative is 0.
So that change happens when the derivative is 0. But what am I actually like on the graph itself, ignoring the derivative for right now?
Going down, you go up.
Exactly. That is exactly what I was looking for. Okay, on this left side I'm going down as I travel. On the right side I'm going up. We're saying that the graph here is decreasing because we always travel from left to right, just like we read. Decreasing on this interval, and then increasing on this other interval. So that's how our graph is split up. So now let's compare it to the derivative. So now something different is going to change. Right here I'm traveling, 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 hit here. Something should change as I go to this side. But this time it's not whether I'm going up or down, because I'm going up the entire time. You cross the x-axis, so what do we know about?
Y values are negative.
All these values are negative. That is a relationship between the two graphs. When the f prime values are negative, we can tell our function is decreasing, or vice versa. If our function is decreasing, f prime of x is negative. So that is our relationship. If f of x is decreasing, f prime of x is less than 0. Or vice versa. This one, it does work both ways. Sometimes it does, sometimes it doesn't. This one, it does. Or if f prime of x is less than 0, f of x is decreasing. And it's very important we can identify that from both directions. Sometimes they'll give us f and say, tell me about f prime. Sometimes they'll give me f prime and say, tell me about f. So what would I say next? If f of x is increasing, what would we know? F prime of x is positive. Or if f prime of x is positive, then f of x is increasing.
Yeah.
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 I thought that was mine. Staff idea. Okay, so this is a very important relationship, and we're actually going to be in section 5.3 for quite a while. I put like 5 of these same relationships, and because we also have to talk about what happens with the second derivative and how to go from graph to graph. So we're going to be in section 5.3 for the next couple of days.
Did you start the
I did.
Alright,
I remembered.
a little late, but.
Good luck, Ben. Okay, so let's do an example. Y equals x cubed minus 3 halves x squared. So I can't just give you a function, I need some instructions. So I want to find the intervals. Where f of x is increasing or decreasing. So we're going to find that by taking the derivative. We're going to let the derivative tell us where is f of x increasing, where is f of x decreasing. So what about the derivative will tell us that information? What are we trying to find out about the derivative?
The y values, if they're positive or negative.
We want to find out if the y values of the derivative are positive or negative. So first, we need to know where did they split. So what was the split between positive and negative? The x-axis, which is a y value of 0. So we want to find y prime and set it equal to 0. And same thing applies. We also want to check where it does not exist, because it's possible that we have a cusp where our derivative is going from negative to positive or positive to negative. So we want to find y prime, set it equal to 0. But we know, hey, we have a polynomial. Our polynomial is always continuous. There's no spots where it doesn't exist. And the derivative of a polynomial is still a polynomial. So we want to take this and set it equal to 0. How do I solve that without a calculator for now?
Factor in it.
Factor.
Very
I could do quadratic formula. Never divide out a variable though, then you get extraneous solutions. So we set it equal to 0, we're finding two y values, 0 and 1. Why is the first one 0? If I set 3x equal to 0, and what do I have to do to get rid of 3? Divide. 0 divided by 3 is still 0. So we found y prime, and this breaks up our interval, but we don't know right now which one's positive, which one's negative. So we need to do what's called a line test. So when we set up this line test, we put our critical points on our number line. These two things were our critical points. And they definitely break our interval up into all positive or all negative. Right now, this interval here is either all positive or all negative. And this interval here is either all positive or all negative. Sorry, it's kind of bleeding over because the highlighter gets bigger. So those three sections, they're either all positive or all negative for the derivative, not for the function, for f prime of x. So we need to figure out, are these positive intervals or are all these all negative? So I'm going to pick what we call a test point. I'm going to pick a value from each interval because every value is either going to come out positive on the green interval or negative on the green interval, so it doesn't matter which number I choose. I could put negative 5 million, and it would come out as positive or negative, just like every other point on this green interval. So what should we pick, though? What's probably the best value to pick, especially if I don't have a calculator at this point? Negative 1. Whole integer nearest to that point where we switch. So I'm going to pick negative 1 as a test point. What about between 0 and 1? Probably the best idea, the easiest fraction to work with on that interval. And then probably 2 on the other side. Closest to 1 is a whole number. And then I wanted to see if the interval is positive or negative for f prime. And that will tell me information about f. If f prime is negative on the green interval, what would we know about f? Not negative. If f prime was negative, f was
At a downward slope.
decreasing. I'm trying to think of my direction from you guys. Decreasing. If we get a positive value here, we know f is increasing. So I should plug it into my derivative. We want to know if my derivative is positive or negative, because then that will tell us information about f. So I would want to plug in 3 times negative 1 times negative 1 minus 1. Now, I actually prefer to plug it into the factored form. And here's why. On the AP test, if they give you something like e, if I try and plug e into 3e squared minus 3 times e, I'm going to have no clue whether it comes out positive or negative. But if I plug it into factored form, we know 3 times e, well that's positive, because e is positive. E is around 2.7, so 2.7 minus 1 is positive. Positive times positive is positive. So that's why I prefer plugging it into factored form, because we don't even care what the number is. I don't care if this is 5 or 5 million. I only care if it comes out positive or negative. So are we going to come out positive or negative? Positive. Because negative 1 minus 1 is negative 2. 3 times negative 1 times negative 2 is positive 6. So if f prime of x is positive here, what does that tell me about f of x? It is positive slope, so it's increasing. So if f prime of x is positive, f prime of x is positive on, oh, not bracket, parenthesis, negative. Negative infinity to 0, then f of x is increasing. This is more information than you would need on your answer. It's just to try and help us make that connection between the derivative and f of x right now. On f of x, or on the answer, you'd really just need increasing, name the interval, decreasing, name the interval. So then we plug in 1/2. Again, I'm going to go with the factored form. 3 times 1/2 times 1/2 minus 1. I have positive here. What happens when I do 1/2 minus 1? Negative. So positive times a negative is negative. Again, it doesn't even matter what our answer is. I don't really care about the value. I care about the sign only. So that means this section here is negative. If I plug in 2, we get positive again. So then this is what we would actually write for the answer. We are increasing from negative infinity to 0. And then have you guys seen the union symbol before? Yeah, it's just set notation's way of saying and, basically. And 1 to infinity. That's where my intervals were positive. And then we are decreasing from 0 to 1. So again, we're trying to make that connection between, if I know this information about my derivative, it tells me about my function. Or I could go backwards. If I knew my function was increasing somewhere, I could say, hey, I know my derivative is positive. Or if I knew my function f of x was decreasing somewhere, I could say, hey, my function is negative. So we are running out of time because we had so much homework to go through since I wasn't here yesterday. So we're going to skip the first derivative test, and then I'm going to have to modify the assignment. So let me double check. We will not be finding the extreme values for sure. So ignore the directions they say on 1 through 6. Just find intervals where f is increasing or decreasing. 21 through 24. Are fine. Except I should have said A only on 21 and 22. And 23 and 24 should be A and B. And then 39. Just don't do 39.
So it's
21 through 22 should be A only.
Okay.
23 and 24 should be A and B.